In this video, I want to have a look at maxima and minima problems to do with quadratics. So quadratic functions always will either have a maximum or a minimum value, and it's all to do with the vertex of the parabola that represents that function. So if, for example, our function represents a concave up parabola, then it will have a minimum value. If it represents a concave down parabola, then it will have a maximum value. So when we've got problems that are represented by quadratic equations, we can find the coordinates of the vertex to find its maximum or minimum value. So we'll start off with these two examples and ask us to find the maximum or minimum value for the quadratic functions that are given. So the first thing you want to have a look at is whether it's going to be a maximum or a minimum value. So because this expression here, this equation, has a negative x squared, that means that our parabola is concave down, so it will have a maximum value. So we're looking for the maximum there. All right, now to do that, we need to find the coordinates of the vertex. There's two ways that we can do it. Because this equation isn't factorized, we're going to use that the x-coordinate of the vertex is that minus b over 2a formula. So our b is our minus 5, and our a is our minus 1 that's in front of that x squared term. So that's going to mean we have minus 5 all over 2 times minus 1, which will end up just giving us 5 over 2, or we could write that as 2.5. So that tells us the x value that will give us our maximum, but we actually need to find the maximum value. So we're going to substitute that 2.5 back into the equation that we had at the start. So we'd have y equals minus 2.5 squared minus 5 times 2.5 plus 14. And putting that in your calculator, just being careful that that negative isn't part of the squared term. And we should end up with 20.25 or 20 1/4. So our maximum value is 20.25 and it occurs when x is equal to 2.5. All right, let's have a look at our second example. Again, the first thing we want to look at is whether it's going to be a maximum or a minimum. So looking at our equation, both our x's are positive, so that means our x squared term is going to be positive. So we're going to have a concave up parabola, which means we're going to have a minimum. All right, now because this is already factored, this probably isn't the easiest way to find the coordinates of the vertex because we would have to expand it first. Instead, we can look at our roots or our zeros or our x-intercepts, and they'd be at x equals 3 and x equals minus 1. Now, because parabolas are symmetric, our vertex is going to have an x-coordinate that's halfway between 3 and minus 1. So our vertex is going to have an x-coordinate of 1, because 1 is halfway between 3 and minus 1. If you're not sure about that as well, you could add them together, so 3 plus minus 1, and then divide your answer by 2 to get that. Okay, so we know the x value where our minimum occurs, but we need to know what our minimum is, so we'll sub it back in. So we've got y equals 1 minus 3, 1 plus 1, so that'll give us minus 2 times 2, which will give us minus 4. So we've got a minimum value of minus 4 at x equals 1. In some examples, we might not be given the quadratic equation. We might have to develop that from the problem that we're given. So this example says two numbers have a sum of 6. For part A, it says show that the product of the two numbers is p equals 6x minus x squared. So let's start off with two numbers. Let's call them x and y. So our first little statement says two numbers have a sum of 6. So that means that x plus y is equal to 6. Now if we rearrange that, because what we're aiming for doesn't have any y's in it, let's rearrange this to make y the subject. So we'd have y is equal to 6 minus x. Now if we're finding the product of these two numbers, x and y, the product is x times y. But again, we don't want that y term in there, so we're going to replace that with this 6 minus x that we got from rearranging. So we're going to have x outside of 6 minus x. And if we expand that out, we'll end up with 6x minus x squared. All right, so that's part A. Part B says find the value of x at which p is a minimum. So again, we're using this formula here. We've got our p equals 6x minus x squared. Because that's already expanded out, it hasn't been factored, it's probably going to be easiest to use our little formula minus b over 2a. And if we sub that in, you've just got to be careful because this isn't written in the way that we're used to. We usually write our quadratics with our x squared term first, and then our x's, and then any constants on the end. So that a has to be the coefficient of x squared, so that's our -1. And our b is the coefficient of our x term, which is 6. So make sure you get these in the right place. So we're going to have -6 over 2 times -1, which would just give us 3. All right, then for part C, it asks us to find the maximum value of p. So we know that occurs when x is equal to 3. So we're going to substitute 3 back into this equation. So we're going to have p is equal to 6 times 3 minus 3 squared, which is 18 minus 9, which will just be 9. So the maximum value of p is 9, and it occurs when x is equal to 3. Okay, I've got one last example. It says Madison has 18 meters of fencing for an animal enclosure. An existing brick wall is going to form one side of the enclosure. So that means that that 18 meters is only going to be 3 sides of it. So if we draw in, if that's our brick wall, then she's going to build an enclosure that comes off that. So that 18 meters makes up that total distance around the edge. So part A says let the enclosure have a width of x meters and show that it has a length of 18 minus 2x. So on our little diagram, if our width is x, that means that's x and that's x, and we want to know what the length is. For now, let's call it y. So we know that those 3 sides are going to be made up of that 18 meters of fencing. So we're going to have x plus y plus x will give us 18. If we simplify that, we'd have 2x plus y is equal to 18. And if we rearrange it, we'd have y equals 18 minus 2x. So our length is that 18 minus 2x. All right, for part B, it asks us to find an expression for the area of the paddock. So we know that the area, because it's a rectangle, is base times height. So area is going to be the length times the width. Now our length is that 18 minus 2x, and our width is just x. So we're going to have x outside of 18 minus 2x. And if we expand that out, we'll have 18x minus 2x squared. All right, part C asks us to find the dimensions that will give us the maximum area. So we're starting off with our expression for the area, which was 18x minus 2x squared. We're going to find x, so the width, that will give us our maximum area, and then sub it back in to find the length. So we're going to use that formula again, making sure that we get the right numbers. So our b will be our 18 and our a is minus 2. So we're going to have minus 18 over minus 2, which will give us, oh sorry, minus 2, hang on, 2 times minus 2, which will give us 4.5 if you put it in the calculator, so 4.5. So that gives us our width, but we need our length as well, and we can use this expression here. So our width will be 18 minus 2 times 4.5, which would give us 9. So the dimensions that will give us a maximum area would be a width of 4.5 and a length of 9 meters. All right, so those are a few examples of problems involving quadratics and maxima and minima problems.